Hello, Chem 1. Today we're going to talk more about compounds. Last time we learned that they have a definite composition. Because of this, there's some really helpful math we can do that helps us out in a chemistry lab setting. We've already talked about the law of definite proportions. It's the idea that if something is bonded together chemically, it's going to be bonded together in a set ratio. We used water. It's a 2-to-1 ratio of hydrogen to oxygen because of that chemical bond. Because of that, we can easily calculate something called the percent composition. If I know that water is 2 parts hydrogen and 1 part oxygen, I can use that information to tell how much hydrogen there should be in a 50-gram sample of water or a 100-gram sample of water because there is a set ratio. Something to remember. Percentages, or percent composition, is simply just the part divided by the whole times 100. That's all percentages. So if I said, hey, here's a bag of Skittles, tell me the percent that are purple, you would count only the purple ones, and then you'd count all the Skittles in the bag, and you'd divide the purple divided by the whole number. And that would tell you the percentage of purple ones in the bag. There's no different to that than what we're doing here. There's just one extra step that you gotta kind of think about. Based on that, we need to review what we learned last time, which is how do we find the whole part, or how do we find the total amount of mass of any molecule? We've already done this. You would take the molecule, you would take the number of atoms you have for each atom, and then you'd get the mass from the periodic table. And then we have 1 oxygen, which is 16. We'd add it all up, and that would tell us the total mass, or what we call the molar mass, which we'll get to when we get to moles. Right now we're calling it formula weight, which is fine. But it'd be 18 grams per mole, or we call the formula weight 18 grams. So that's how you calculate the whole part. The next part would then be just calculate the part you're looking at. So let's try a couple of examples. This says determine the percent composition for H2O. I'm going to walk you through the procedure here. I would try to do it as closely like I do it as possible. It kind of keeps things organized for you. The first thing we're going to do is we're going to list our elements. And then we're going to list how many of each element I have. And then we're going to look up the mass from the periodic table. We know that hydrogen is 1.01 and oxygen is 16.0. Then we're going to multiply it out, and then we're going to add them together. And we'd only keep 3 sig figs there. The reason that I would list out every element is because a lot of times people punch them all into their calculator at once, but then they don't know how much they just have for hydrogen or how much they just need for oxygen, and they have to go back to calculate that, because to calculate the percent composition, you need to know the individual parts as well. So for instance, if I wanted to know the percent comp of hydrogen, I'd take the part that's hydrogen, 2.02, and I would divide it by 18 and then times it by 100. If I wanted to know the part that was oxygen, I'd take 16, I'd divide by 18, and then I'd multiply by 100. So if we take a look here at the completed equation, there's our hydrogen, there's our oxygen, there's our total, our whole part. And after we divide the part by the whole part, we would get 11.2% hydrogen and 88.9% oxygen. Now, if I would have asked you at the beginning, how much hydrogen is there compared to oxygen, you might have said something like, oh, there's 2 hydrogens, so maybe it's like 2/3, maybe 66% hydrogen. By atom, that would be correct. But hydrogen is a much smaller atom. Oxygen is much larger. So by mass, which is typically what we measure in a chem lab setting, that is not correct. That's not what we'd see in the lab data. And it's because of the different size atoms. And that's why we always have to account for the mass in a percent comp of a molecule. Here's another one. This one's a little more complicated because we have more elements, but it's nothing to be scared of. Nitrogen, there's 2 of them, which each have a mass of 14, 28. We have hydrogen, and there are 8 of them because 2 times 4 and they each have a mass of 8.01, which is 8.08. We have carbon. There's one of them, and it's 12.0. And we have oxygen, and there are three of them, which is 16.0, which is 48. So here we've already done the 4 different parts in like 30 seconds, maybe 45. Then we'd add all those together, and we divide each part by the total. So let's take a look at the completed problem here. If we look at the completed problem, we can see that our total mass of everything together was 96.1. And then we would take every part and divide it by the 96.1. And that would give us the percentage of that specific part. So it's really just how you'd find a percent of everything. The only difference is you have to take into account the mass of the different types of elements. One more quick thing here before we end. It's the law of multiple proportion. If you think about it, the law of definite proportions could help us identify unknown substances in lab. If we knew how much oxygen was in that substance and how much hydrogen is that substance, you might be able to identify it as water. One sticking point to that, though, the law of multiple proportions says that sometimes two atoms bond together in different ways. So for instance, carbon and oxygen, the most common molecule that they make is carbon dioxide, but they can also make carbon monoxide. And hydrogen and oxygen can make H2O, but they also make hydrogen peroxide, which is H2O2. Nitrogen and oxygen make all kinds of different molecules. Because of this, sometimes the percent composition isn't straightforward and doesn't tell you exactly what the ratio is between those two elements. It's just something to think about that is possible. That's really all we wanted to cover today. The most important thing you learned today is the percent composition math. You will continue to use that throughout this semester and some into the next semester. Good job today. We'll see you soon.